Hi viewers, this is a problem related to Caley Hamilton theorem. If A is equal to 2, 1, 2, 5, 3, 3, minus 1, 0, minus 2, verify Caley Hamilton theorem and then find A inverse. Right, this is the given matrix. So the statement of Caley Hamilton theorem is every square matrix satisfies its characteristic equation. Square matrix means of order n by n. Here this matrix is a square matrix, its order is 3 by 3. Now what is the characteristic equation? Det of A minus lambda I is equal to 0 is the characteristic equation. Now we have to show that every square matrix A satisfies its characteristic equation. Now we will find det of A minus lambda I equal to 0. So this is A minus lambda into I. I is a 3 by 3 matrix, 3 by 3 identity matrix, 1 0 0 0 1 0 0 0 1. So A minus lambda I equal to 0. Now we will find this 2 minus lambda, 1 minus 0 is 1, 2 minus 0 is 0, 5 minus 0 0, 3 minus lambda into 1 is 3 minus lambda, 3 minus 0 is 0, minus 1 minus 0 is 0, 0 minus 0 0, minus 2 minus lambda is minus 2 minus lambda, which is equal to 0. So the det of A minus lambda I is equal to 0. Now we will find the det of this equation. 2 minus lambda into 3 minus lambda minus 2 minus lambda minus 0 into 3 0, minus 1 into, remove this row and column, 5 into minus 2 minus lambda minus 3 into minus 1, minus of minus plus, plus 3, plus 2 into 5 into 0 is 0, plus 3 minus lambda into minus 1, minus of minus is plus, which is equal to 0. Now 2 minus lambda into multiply these two, we will get this minus 1 into multiplication, 5 to 10 minus this and the multiplication. So after multiplying this whole thing, we will get the lambda cube minus 3 lambda square minus 7 lambda minus 1 equal to 0. Now we will verify the Caley Hamilton theorem. So replace, we have to show that the given square matrix A satisfies the characteristic equation. Now here substitute A cube minus 3A square minus 7A minus, in place of 1 keep the identity matrix I equal to 0. Now for this find, for this A cube, first find A square. A square is equal to A into A. You know matrix multiplication. This is the result, and then with this A square multiply A. So this is A square and A, then the resultant matrix is this. Now A cube minus 3A square minus 7A into I. This is A cube minus 3A square minus 7A minus I. So just we check the first element, 36 minus 21 minus 14 minus 1 equal to 0. So all the values are 0 here. So we have proved that det of A minus lambda I is equal to 0. So Caley Hamilton theorem is verified for the given matrix. Now we have to find out A inverse. So to find out A inverse by using Caley Hamilton theorem, it is very simple. We know this equation A cube minus 3A square minus 7A minus I, that is in the problem. Now multiply both sides this equation with A inverse. So A inverse of A cube minus 3A square minus 7A minus I equal to 0. Now this implies A inverse into A cube is A square minus 3, A inverse into A square is 3A minus A inverse into A is I, so 7I minus I into A inverse is A inverse, which is equal to 0. So A square minus 3A minus 7I minus A inverse is equal to 0. So this implies take this A inverse this side, then A inverse is equal to A square minus 3A minus 7i. Now substitute in the A inverse equation. A inverse equal to A square, this is A square minus 3A, multiply A with 3, then we will get this minus 7i. I is the identity matrix, multiply it with 7, then you will get this. Now 7 minus of minus 6, 7 plus 6, 13, 13 minus 7 is minus 6. So we will get these values. So this is the value of A inverse.